Hi guys, today we're going to be learning about arithmetic sequences. An arithmetic sequence is a sequence where the difference between consecutive terms is constant. What that means is every time to get from one number to the next, you're adding or subtracting the same number. So we have two different formulas we're going to look at today, and got to add something here. Okay, so we have recursive, which is really just good to get you from one term to the next. A recursive formula can also be used to generate the first 5 terms of a sequence. And then we have the explicit formula, which is good for if you want to find the 100th term or 52nd term. So I would make sure, if you're going to take the ACT here soon, to make sure you know that formula. It's very helpful. There's usually a sequence question on the ACT. Okay, so let's break down what does this mean. A sub 1 is the first term of the sequence. So there's going to be a number filled in here. So here's an example. Maybe our first term is 5. Okay? D is the common difference, is what you're adding or subtracting. So in this example, D is 3, and our first term, A sub 1, is 5. This A sub n minus 1 just means the previous term. So all this means is if you have a sequence and we have 5, we'll write down 5 and then add 3 each time. So 5 plus 3 would be 8. And then 8's are now previous term. 8 plus 3 gives me 11. This is how a recursive formula works. An explicit formula, you plug in what the first term is, so A sub 1. So if I had this, if I'm using this sequence, I can use the recursive formula to write an explicit formula. I can write A sub n equals, my first term is 5, so I write 5 plus, this is kind of like A sub n minus 1. So we just write n minus 1, and then our common difference is 3. And I could simplify this. I could distribute, and then add like terms. So then my explicit formula would be 2 plus 3n. So that's how an explicit formula works. If we just want the explicit formula, you leave it like that. N represents the term we're trying to find. So if we want the 50th term, we would plug 50 in for n, okay? So I'm going to erase that because that won't mean anything if you just look at PDF notes. So there's some weird notation with sequences. Just roll with it. Okay, next slide. Is it arithmetic? So on the homework, the first few problems, is it arithmetic? Find the common difference. So remember, you got to be adding or subtracting the same number each time. So here, the pattern's add 3, add 3. So yes, and then the common difference is 3. Here, we add 3, then add 5, then add 7. Not arithmetic. Common difference is not constant. Okay, the next one. How do we get from 1 to 5? Add 4. 5 to 9. Add 4. Add 4. Add 4. Is it arithmetic? Yes. And we say the common difference is 4. So that's how you're going to tackle 1 through 5 on your homework. So use for 1 through 5. Okay, analyzing an arithmetic sequence. What is the 100th term of the arithmetic sequence that begins 6, 11, ... Okay, so use explicit formula if you want the 100th term. AN equals A sub 1 plus D times N minus 1. I'm going to flip it around just a little bit. Okay, so A sub 1, what's the first term? Okay, then what's the common difference? How do you get from 6 to 11? 5. So that's D. Then you plug it in. A sub N equals 6 plus 5 times N minus 1. And then let's go ahead and distribute. And then I add my like terms. So it's going to become 5n plus 1. I'm going to put n first because it looks better. Okay, then what is the 100th term? This is saying n equals 100. If they ask for the 52nd term, you plug in 52 for n. So a sub 100 equals 5 times 100 plus 1. So our 100th term is 501. And there we go. There's the 100th term. So that's something you might see on as an ACT question. So you got to use the explicit formula. Whatever term you're looking for, that's what you plug in for n. Okay, next one. Write the explicit and recursive formula for each sequence. So let's start by recalling what the explicit formula is. And then let's recall what the recursive formula is. So I'm going to underline where we plug in numbers. We always plug in whatever a sub 1 is and d. So a sub 1 is 10. D is also 10. So then we plug this in. A sub n equals 10 plus 10 times n minus 1. Okay, let's go ahead and distribute. And then this simplifies, because these would cancel out, would just be 10n. Okay, recursive formula. Every year, I have a kid that remembers to plug in what D is, but they forget to tell me what A sub 1 is. So don't forget to do that. So we would just plug in D. D is 10, and then A sub 1 is 10. So here's my two answers. All right. Next one, we have negative 21, negative 18, negative 15, and negative 12. Okay, A sub 1 is negative 21. What's the pattern? This time, we're subtracting 3. So that is what D is. So then we write A sub 1 is negative 21 plus, I'm going to go ahead and put minus actually, minus 3 times n minus 1. And then we distribute. So this becomes A sub n equals, I'm going to put n first, negative 3n minus 18. There's our explicit formula. Recursive formula, A sub n minus 1 minus 3, and then we write A sub 1 equals negative 21. There's my two answers for part B. Okay, part C, identify what's the first term. That's A sub 1. What's the pattern? We're adding 4. So that's the common difference. D equals 4. and we plug that in, a sub n equals 3 plus 4 times n minus 1. Redistribute. Okay, this becomes 4n minus 1. There's our explicit formula. And then a sub n minus 1 plus 4. And then don't forget to state what a sub 1 is. The first term is 3. Okay, you're going to use these examples. So, on 6 through 8, okay, I'm going to highlight. Use 6 through 8. Use for 6 through 8. Recursive. Use for 9 through 10. Maybe I'll highlight that. Okay. Okay, find the 100th term of the sequence. We just did this. So you have to start with the explicit formula. A sub n equals a1 plus b times n minus 1. Okay, a sub 1 is 10. b is 10. So I write 10 plus 10 times n minus 1. And then we distribute. And we get a sub n equals 10n. Now, find the 100th term. N equals 100. So then, I plug in 100. This would be 1,000. Okay, next example. First term, a sub 1 is 3. D is 4. So then I write a sub n equals 3 plus 4 times n minus 1. Distribute. Okay, combine like terms. Now remember, we're finding the 100th term, so plug in that n equals 100. So, oops, that should be 100 there. So the 100th term is 399. Okay. Arithmetic mean. So when you're given a sequence and you don't know what the middle term is, you find the average. Okay? Add the two numbers together, divide by 2. That's how we find the missing term. And you're going to use this for problems 13 through 14. Okay? So, find the missing term. 15 plus 59 divided by 2. So 15 plus 59 is 74. Half of 74 is 37. So this is the missing term. Okay, next one. 132 plus 98 divided by 2. So that'd be 230 divided by 2, which is 115. 115 is the missing term. So, arithmetic mean's not too difficult, just find the average. Remember, mean is the average. Okay, last few examples. Given the explicit formula for an arithmetic sequence, find the first 5 terms. You're going to use this for problems 15 through 16 on the homework. Okay, so remember, if we wanted the 100th term, we plugged in 100 for n. If we want the first term, we're going to plug in 1. So 3 minus 4 would give me -1. Okay, there's the first term. If I want the second term, I plug in 2 for n. Okay, so 3 minus 4 times 2 would be -5. Then, if I want the third term, I plug in 3 for n, and I keep jumping the gun. 4 times 3. Which would give me -9. If I want the fourth term, I get -13. If I get the fifth term, I plug in 5. And that would give me -17. So your answer is -1, -5, -9, -13, -17. Another way you could have done this is once you get this term and this term, ask yourself what's the pattern. You're subtracting 4. So you could just go -4 until you get to the fifth term. Okay, so that's what you do for that. When you're given the explicit formula, you got to plug in 1, got to plug in 2, got to plug in 3, plug in 4, plug in 5 for n, and you find all those numbers. The next one is so much easier when you're given the recursive formula and asked to find the first 5 terms, because they give you the first term. This is the first term. Make sure you write down 3. From there, subtract 10. Okay? So, 3 minus 10 equals -7. Minus 10 would be -17. Minus 10 again, -27. Minus 10 again, -37. Okay? That's what you do for problems 17 through 18 on the homework. And that's sequences for you guys.